How did Viking builders create storm-resistant homes without using nails or cement? Their methods may surprise you far more than you expect. A North Atlantic storm isn't just bad weather. It's a relentless natural force capable of ripping roofs away and splitting stone. And yet, along these brutal coastlines, the Vikings built their dwellings. They constructed vast wooden halls that could stand for centuries without a single iron fastener or drop of mortar. These structures weren't merely shelters, they were almost alive, shaped by the hard-won knowledge of countless generations. Viking homes flexed under pressure, swayed with the wind, and outlasted tempests that would destroy modern buildings. Their secret wasn't brute strength, but an ingenious design philosophy built on controlled flexibility, the same principle that made their legendary ships so resilient. We tend to imagine Vikings solely as warriors, but they were among the most talented woodworkers of their age. They could read timber the way we read text, understanding how to use its natural grain and strength rather than forcing it into rigid forms. This craftsmanship was born from necessity. Survival demanded it. Keep watching until the end, and you'll discover how one astonishing style of wooden joint, carved with precision worthy of a jeweler, helped their houses survive the most violent storms nature can deliver. What if everything you thought you knew about Viking homes was mistaken? Erase the picture of a cramped, smoky shack where people huddled in filth with animals. The real structures were far more sophisticated. These weren't simple huts, they were timber palaces. The Longhouse, or langhus, was the heart of a Viking settlement. Some were so large they stretched up to 80 meters in length, similar in size to a modern apartment block. Within these expansive halls, entire families and their extended clans lived together. Dozens of people, warriors, servants, artisans, all found space under one roof. A longhouse wasn't just a home. It was a fortress, a storeroom, a workshop, and a ceremonial hall all at once. It had to shoulder enormous loads of winter snow and withstand winds approaching hurricane force. Achieving this demanded engineering skill rarely associated with this era. The center of the hall was a vast, open space. A long fire pit burned constantly, and its smoke escaped through openings in the roof. This was where daily life unfolded, where leaders met, choices were made, and stories were shared. This fire-lit hall formed the beating heart of the community. Contrary to popular belief, part of the longhouse was indeed reserved for livestock during the winter, but not because of primitiveness. It was actually brilliant engineering. The animals were kept in their own section, and the warmth they produced helped heat the living quarters, conserving precious fuel. When you pictured a Viking house, did you imagine something on this scale? Share your impressions, and don't forget to follow the channel for more forgotten innovations from the ancient world. Now we reach one of their most important secrets, something hidden literally at the base of every longhouse. The main threat to wooden buildings in Scandinavia wasn't the wind. It was moisture. Constant rain, melting snow, and saturated soil slowly rotted wood from the ground up. Vikings understood that any structure built directly on the earth was doomed, so they devised a simple and timeless solution: stone. But this wasn't a cemented foundation, it was dry stone construction, stacking carefully chosen rocks without any binding mortar. Master builders selected flat stones and arranged them into low walls outlining the house's footprint. The goal was to lift the first and most crucial horizontal beam, the sill beam, called the sill stalker, above the wet ground. This timber acted like the house's soul, supporting the weight of the walls above it. Thanks to the raised stone base, It stayed dry and well ventilated, preventing rot. Air circulating beneath the beam whisked away moisture. The stones also helped block cold winds from passing under the floor and acted as a barrier to rodents, protecting stored food. "Lift with the lever, easy. Hold it steady." The precision behind these foundations is astonishing. The stones fit together so tightly that wind and water had virtually no entry points. This work demanded patience and a deep, almost instinctive grasp of geometry. Every stone had one perfect place. Imagine how long it must have taken to prepare the stone base for an 80-meter hall, entirely by hand. But even the best foundation means little if the walls can't withstand the elements, and this is where the Vikings unveiled the influence of their greatest skill: shipbuilding. In the next section, we'll explore how techniques born on the sea transformed their architecture on land. What you're about to learn reshapes our entire understanding of early architecture. When most people think of wooden walls, they imagine a log cabin with stacked horizontal logs or modern planks nailed into a frame. But the Vikings chose a completely different path, one inspired directly by their seafaring traditions. Their houses borrowed the same principles used in their sturdy longships. The key was a building style known as stave, or post and beam construction, one of the most distinctive and unconventional methods in architectural history. It was designed not to resist nature, but to cooperate with it. Drink this brew, it'll cut the chill. Instead of piling logs horizontally, builders set tall, upright pillars, the staves, at the corners and along the walls. Into these massive posts, they carved deep vertical channels. This carving required incredible control and a sharp eye. Horizontal planks were then slid into these grooves, one above another. These planks, called tilia, formed the wall surface. They weren't nailed or glued. They simply rested in the grooves. This is where the brilliance of Viking design becomes clear. Wood is alive. It swells when damp, shrinks in heat, and constantly moves with the seasons. In rigid walls, this movement causes cracks or warping. But in a Viking longhouse, the planks were free to shift slightly within the grooves. When fierce winds slammed against the structure, the walls didn't resist until they broke. They flexed. The boards bowed and shifted just enough to absorb the shock, like a ship's hull riding a wave. This built-in elasticity made the entire structure astonishingly stable. Walls formed this way could endure wind pressures that would tear apart modern rigid frames. They survived because they were never meant to stay perfectly still. Tap the like button if you never knew Viking walls could bend like a ship's planks. But what supported the roof? Here comes a surprising truth. In many longhouses, the exterior walls carried none of the roof's weight. They were essentially weather shields, not load-bearing structures. Listen to that wind tonight, little one. The gods are restless. The immense weight of the roof, often covered with thick layers of turf and heavy winter snow, rested on an entirely separate internal framework. This was the true skeleton of the house. Two long rows of enormous posts ran the full length of the hall, driven deep into the ground. Hewn from ancient trees, these posts were the giants of the structure. At their tops, they were tied together with heavy crossbeams. Resting across these beams lay the ridge beam, the longest and thickest timber in the entire building. This ridge beam functioned as the spine of the house, supporting the entire roof. This layout, known as the ship type or arched hall design, created a vast open interior without internal walls. The outer walls were merely a protective skin. The inner pillars bore all the weight. This allowed the Vikings to build halls of extraordinary size and width, And this wasn't just practical, it shaped their way of life. With no internal dividing walls, the entire household lived together in a single communal space. This arrangement strengthened social ties and created a deeply unified community environment. You've carved that cleanly, a job worthy of a chieftain's hall. The internal pillars weren't purely structural. They often carried intricate carvings, depictions of gods, heroes, beasts, and myths. They held up the roof, but also symbolically upheld the spiritual world of the family. As long as the pillars stood, so did the clan's honor. Because the outer walls didn't carry vertical loads, they could be built lighter and modified more easily. Sections could be removed, new openings added, or repairs made without risking collapse. The internal frame remained untouched. Can you imagine living your whole life inside one enormous hall, with almost no private rooms? But now a crucial question arises. How were gigantic beams joined together without nails? In the next part, we reveal the secret of the wooden nail, a fastener that didn't rust, didn't loosen, and actually grew stronger over time. Imagine the challenge. You must fasten two enormous timbers that will support tons of roof weight. Iron nails are out of the question. Metal was precious and reserved for weapons and essential tools. All you have to work with is wood. The Viking answer was ingenious, the trenail, or wooden peg. But this wasn't just a stick hammered into a hole. It was a carefully engineered fastener that actually strengthened with age. To make a trenail, builders chose the densest and toughest woods available: oak, ash, or juniper. The peg needed to be harder than the beams it joined. First, a craftsman would drill a clean hole through both timbers using a long-handled auger. The bore had to be perfectly smooth, or the joint would weaken. Then came the peg itself. Instead of carving a simple, round dowel, the Vikings often shaped it into a square or octagonal profile. These sharp edges bit into the surrounding wood, gripping it more firmly. But the real magic was in the preparation. The peg was dried to the point of near brittleness, left near a fire or in the sun until it shrank slightly and became hard as bone. Only then was it driven with force through the drilled hole, passing through both beams. Tiny wedges were tapped into each end for extra locking strength. Once in place, something remarkable happened. The peg slowly reabsorbed moisture from the surrounding timbers and the cool, humid Scandinavian air. As it swollen, it expanded with enormous pressure, filling every tiny gap. Over time, the joint became a single, solid mass. Iron nails corrode and eventually weakened the wood around them. But a trenail aged like living bone. The wetter the climate, the stronger it grew. In a world of storms and endless damp, this was the perfect technology. Now picture an entire building held together by countless such wooden fasteners, each one a tiny piece of evolving, self-tightening engineering. This was the backbone of Viking houses and ships alike. But the trenail was just one element of a much larger language of woodworking the Vikings mastered. Every carpenter spoke this silent language, a vocabulary of shapes and joints instead of words. And the foundation of this language was the mortise-and-tenon joint. One beam was carved with a projecting tongue, the tenon. The other was cut with a perfectly matched cavity, the mortise. When the two were fitted together, the connection locked in place, preventing movement in all directions. No nails, no metal, just the shape of the wood itself. The Vikings developed dozens of variations of this joint, through tenons secured with wedges, hidden tenons invisible from the outside, and angled tenons designed for rafters. Each type served a specific purpose. Another essential technique was the notch. When two logs needed to intersect, especially at corners, each was carved halfway through so they fit together tightly. This method, often called a saddle notch or claw joint, created smooth, stable corners that resisted spreading under roof pressure. It demanded extraordinary accuracy and mastery of the axe. See how snug that is? Not the smallest draft will slip through. Stronger than any shield line. To secure major structural connections like rafters meeting roof beams, builders often combined multiple joint types. A notch here, a tongue and groove there, all locked together with a trenail. It was a multi-layered safeguard system. The Viking axe was not just a cutting tool, it was a sculpting instrument. With it, craftsmen created joints so precise they almost snapped into place by themselves. Each notch and groove was carved with deep awareness of how the timber would behave under load, moisture, and time. This carpenter's language embodied centuries of accumulated knowledge. Masters taught apprentices which joint could bear a roof beam and which was best for a corner post. It was knowledge as valuable as treasure, and you can still find these joints in surviving Viking ruins today, holding fast after 1,000 years. But even the most perfectly carved frame can't shield a home from the freezing winds of the North Atlantic. To solve that problem, the Vikings wrapped their houses in a material far more effective than wood, a thick, living layer of earth. No matter how sturdy the wooden skeleton was, it couldn't block the relentless cold. Simple planks alone would freeze solid. The Vikings needed insulation, and they found the perfect solution right beneath their feet: turf. In forest-poor areas like Iceland and Greenland, turf wasn't just insulation. It became the main building material. Those famous Viking turf houses were essentially wooden frames buried inside walls of earth. Builders cut large blocks from the grassy topsoil, roots and all. Steady now, another block before the wind shifts. These sawed bricks were stacked to form walls over a meter thick. Grass roots intertwined as the blocks settled, tightening the structure over time. The massive thickness of the walls provided immense thermal stability. They held heat in the winter and stayed cool in the brief summer. This was a living blanket. Sawed walls were completely windproof. No draft, no matter how fierce, could cut through a meter of earth. Inside the longhouse, it might be smoky and dim, but it was warm even while blizzards howled outside. Turf houses blended seamlessly into the land. From a distance, they resembled grassy hills. And unlike timber, turf was naturally fire-resistant, a crucial advantage in homes lit by open flames. These earthen walls required care. Over time, they settled and occasionally had to be replaced. But the warmth and protection they offered made them worth every hour of labor. The roof, however, posed an even greater challenge. How could the Vikings keep it from leaking, blowing away, or collapsing under snow? Their solution was one of the most brilliant systems ever invented, and it's still used in parts of Scandinavia today. A roof in the north had to survive everything nature could throw at it. Months of rain, sudden storms rolling off the sea, and snow piling up in heavy drifts. A simple wooden roof could never endure those conditions by itself. So the Vikings devised a layered roofing system that was as durable as it was clever. First came the structural heart of the roof, a framework of powerful rafters rising from the walls and meeting at the ridge. These rafters were locked in place by an intricate network of beams and braces, all joined with the same carpentry language of mortises, tenons, and wooden pegs. Once this skeleton was secure, the builders added what seemed like a delicate layer: thin birch bark sheets. Why bark? Because birch bark is naturally waterproof. Each sheet was laid so it overlapped the next, like fish scales, forming a continuous barrier that shed rain with remarkable efficiency. Bark does not rot easily, and its flexibility allowed it to move with the wood beneath it. This was the first shield against the elements. But the real weight-bearing and insulating layer came next: sod. Huge slabs of turf, cut thick and heavy, were hauled up and placed directly on top of the bark. A young builder might joke, "Feels like roofing with farm fields," as he heaved a slab above his head. These sod layers served multiple purposes at once. Their combined weight pressed the bark firmly into place, sealing every seam. The dense earth absorbed rainwater, releasing it slowly rather than allowing it to run inside. And just like the walls, the grass roots eventually knit together, forming a single massive mat that anchored the entire roof like a living net. A well-made sod roof could last decades. Its sheer mass kept it from blowing away in storms, and its thickness insulated the longhouse from the cold. A winter's snowfall actually helped. It added another layer of insulation. Inside, families were kept warm by the trapped heat, even when ice crusted over the world outside. These roofs weren't perfectly neat or flat. They swelled in gentle curves, sometimes even sprouting flowers and small plants. From afar, a Viking longhouse looked like it had risen naturally from the earth, shaped by nature itself rather than carved by tools. Yet even after all this effort, the bark, the turf, the angled joints and wooden pegs, one last challenge remained: fire. With open flames burning day and night for cooking and warmth, these homes needed a way to breathe without letting the cold pour in. The solution was simple but effective: a small opening in the roof that acted as a chimney. Smoke drifted upward and out, while the low ceilings kept heat trapped near the floor where people slept and worked. Over time, soot darkened the rafters until they were almost black. But this layer of soot actually protected the wood, making it more resistant to moisture and pests. What started as a side effect became another accidental advantage of the Viking design. With all these elements together, the solid timber frame, the tight joints, the trenails, the turf walls, and the living roof, the Viking longhouse became one of the most impressive buildings of the early medieval world. It was warm, stormproof, and strong enough to last for generations. And these weren't just homes, they were community centers, workshops, feasting halls, and safe havens against the unforgiving climate. Families gathered around the central fire, storytellers recited sagas, and children learned the skills that would define their futures. If you step inside a reconstructed longhouse today, you'll feel it: the hushed calm, the dim glow of firelight, the thick walls holding back the wind. It's as if the past is still breathing in the darkness. You can almost hear a voice say, "Close the door, the cold follows you like a shadow." The Vikings were not merely warriors and sailors. They were builders of extraordinary ingenuity, crafting homes that were as resilient as the people who lived in them. Standing against wind, against snow, against time itself. If you're enjoying this deep dive, make sure to subscribe and turn on notifications so you never miss the next episode.